Hello, my name is Colin Blackburn from the OME team in Dundee. Today I'm going to talk to you a little bit about how to interact with your data in OMERO through the command line. So what am I going to talk about? Well, first I'll give an overview of the CLI, the command line interface to OMERO, and then I'll go through the various ways of working with data from the CLI, so that's creating, finding, getting, deleting and moving. So the CLI is a client, just like Insight and the web. It's driven from the command line. It's a Python-based system. It does system administration, deployment, advanced user tools. Most of the commands can work remotely, so you can talk to a remote server. It offers tools for various users, facility managers, system administrators and developers. If you use bin OMERO help, you get a full list of all of the commands available. And as the CLI is updated from time to time, it's worth checking there just to see what is and isn't available. And then from there you can find individual help on particular commands. So the ecosystem for the CLI, broadly, it has commands that are relevant for administering users and groups, administering the server, meta commands, which do things like run commands from files or invoke scripts or drop you into shells. And then the commands that are the main focus of this talk, which are data commands. These are for dealing with data. There's some overlap between quite a few of these commands, and this Venn diagram vaguely represents some of that, although it's not quite so exact. So working with data, first of all, creating stuff. So in order to create data on the OMERO server, we obviously have import, which is the subject of another talk I've done. And then we have things like upload, tag and obj, which is the main workhorse command for creating objects. So the CLI import, this was dealt with in my talk this year on the extensible import, which can be found on the downloads page. It allows you to import images to an OMERO server from the command line. It's effectively for people who want to use some sort of shell-based system or a web front end. And the command line supports the same file formats and functions in much the same way as the Insight client. And then it extends that by adding options on the command line that aren't available in Insight, such as the way in which imports are made or the way in which targets are identified. So the import is fairly basic. You use bin OMERO import and you pass it the file name you'd like to import or the directory containing the files. Once it's imported, it gives the output, and it gives it at the moment in a list of pixel IDs on standard out and some other information on standard error, but we're looking at ways of improving this data by providing options which will give you the image IDs directly, for instance. So upload is the command you need to use if you want to get files onto the OMERO server. You use bin OMERO upload and you give it the name of a file, and you basically get back the ID of the file that's uploaded. So this transfers the file from your local file storage to the server. It's kept under the OMERO data directory under /files as an ID numbered file. But it's copied exactly as it is, it's just renamed at the server end. And we can just check whether that's been uploaded using the obj command, so we get the original file with that ID, get its name, and we see it is the right name. The name is stored in the database, by the way. It's not the name of the actual file in the data directory. So creating tags. So tags are things we can use to annotate files, imports, data sets. Pretty much anything in the system can be tagged. Tags allow you a way to actually sort of view the data from within Insight and the web client, where you can actually look at all the particular images imported that have a particular tag, for instance. We also have various ways of automatically tagging and doing searches based on tags from web apps. But from the command line we can basically list tags. We can list tag sets, which are tags that themselves contain more tags to create a hierarchy of tags. We can create the tags and the sets. We can import sort of tags and tag sets from JSON file. That's a JavaScript object notation file, which is a fairly standard way of transferring data these days. And we can link tags to other things within the system. So effectively we can add a tag as an annotation to another object. So creating, managing and viewing tags. Here are some examples. We create with the name of a tag 1, we create another one with the name tag 2, then we create a set, and for that set we give it both its name and we tell it give it the IDs of the tags we'd like to include at this stage. We can link tags further down the line if we want to. And then we can use the tag list command to list the tags, and this will give us a hierarchical view if that's appropriate, if we do have tag sets with tags within them. And finally we can link a tag, so if we use tag link and we give it the ID of an image 51 and we give it the ID of a tag 1, it will create an image annotation link which is effectively linked that tag to that image. Pardon me. So creating stuff using obj. As I said, this is the workhorse of the data creation commands. This pretty much allows us to create any object in the system that can be created from the command line. We can create new objects, update existing ones by setting fields. We can nullify fields on existing objects. We can also deal with map annotations and fields within objects that are lists. So all of these things are available to us. And as you see here, we can give the class, so the name of the model object, so for instance a project, and then we can give it the fields we want to set or nullify or get, for instance. So looking at a simple example here, we create a new dataset called dataset 1, and you see we get back the ID, so dataset :1. And this is the standard format I talked about in another talk, so this could then be used directly and passed to an import command to import into that dataset. We can use update. In this case we use update on that dataset to add a description to the dataset. Get will get the name of an individual field, here it's the name, and then get without a field specified will get all the relevant top level items. So in this case it's the description, the ID, the name and the version. It doesn't get the sort of more nested information such as the details of ownership and the like, although that could be drilled down to using HQL, which I'll mention later on. We can pardon me, we can create and link containers. So here we create a project with a name. We then create a project dataset link, giving it the parent, which is the project and its ID, and the child, which is the dataset and its ID. And this creates a project dataset link, so now that dataset is within that project. We can do the same for datasets and images. And as you see, we can then query the child or the parent or either of those. And what we've got at the end of this is effectively a project dataset hierarchy with a single image within it. And we can also use obj to manage annotations. So the file we uploaded earlier, which was the original file with ID 275, we can create a file annotation based on that file. So the file annotation effectively links to that file. We can then link that file annotation to our image. So we create an image annotation link, as we see here, and we get that back. That's the ID 2. In addition, we could create a new map annotation. So here I've given it a name of domain and a namespace of example.com. Namespaces aren't required. They can be useful for helping you find objects within the system because you can query based on namespaces, and they are used for some particular objects within our system for certain reasons. So for instance, certain namespaces are used to allow objects to be annotated from within Insight, for example, but details of that could be found in our documentation. So in this case we create a map annotation 6, and then we set a sort of a map value to that. So it's a key value pair. So we're using the key 1, and we're using the value of and we're using a URL there. And then we can get it on the next line, as we see. So we get the value attached to key 1, and as you see, it's a URL. So this can be a useful way of storing additional information on objects by creating these maps. And then finally, I link that map annotation to the image as we did with the file annotation up above. And we've got an image annotation link there of 3. Pardon me. We can use, by using the output from some of these commands, we can effectively automate or semi-automate the workflows. So for instance here, we capture the project:ID in the variable project, and similarly the dataset one in the variable dataset. And then we can create the project dataset link using the variables project and dataset. And further down we can actually use the variable dataset in our input command. So this again allows us to create a project dataset image, but in this case it's sort of semi-automated, and as you could see this could be scripted to do much more complex things than this. And if we have a quick look at what we would see in the web client with here, you can see on the left hand side we've got the projects and datasets we created with the files imported, and if we look over on the right hand side we can see the tag, the key value pair, and the file attachment, and all of these were just done on the command line a few seconds ago, as you can see. So working with data, now looking at finding things, so I'm going to mention a couple of commands here which are basically search and HQL. The search will search for object IDs by string. There are quite a few arguments you can give it. They restrict things like the date, or whether you want the IDs only returned. So this really is whether you, both for restricting the search and for providing the output in a form that you can deal with in sort of a bash script, for instance. So here we can search for a particular type of object, and we can have a query, essentially the search term we want to use. So here we search for all the images that have DV in them. So in this case it would find images with DV in their name, and as you see it's found the 2 images I imported earlier. Pardon me. If we use IDs only rather than, and the style CSV, rather than getting back the table of data which includes the name, the acquisition date, and a lot more information that I've truncated there, we just get back a very simple table with the object class names and the ID. So again, these could then be used in an automated way by parsing this CSV output. HQL allows you to execute an HQL query. HQL is the Hibernate query language. It's very similar to SQL but a little bit different because it's dealing with objects within our system. It's mapping essentially the database to the objects. You can find examples within our documentation, and if you know SQL you shouldn't have too much difficulty, but as I say, there are a few little differences in there. Similarly, we've got a whole series of options here. We can limit how many things we want output, or we can get the output in different formats as we did before. We can run the command as an admin or all if we want to query across several groups, which can be useful if you're admin because you may want back more information than an individual user would be allowed. So here are a couple of examples. In the first one we're getting the ID, the name and the file set ID of an image where the IDs are above a certain number, and as you can see we've got 3 returned there, and the file set IDs are on the right because we've selected the ID name and file set ID. In a second example I just use HQL on its own, and this drops us into an HQL shell, so we can then enter queries repeatedly. So if you need to do quite a little bit of querying, then dropping into the HQL shell is a good way of doing that. And I'm pretty much running the same search here, but I'm just ordering by the IDs in descending order. And both of those will effectively allow you to search for things. You can obviously put much more complex queries in than that, joining across tables, etc., and get quite a lot of information out. And as I say, there are examples in our documentation. So getting stuff out, well, one way we might want to get things out is to export data. So we can use export in a couple of different ways. We can export either as we can export an image, and it will normally be exported as an OME TIFF file. So here we give it the ID of the image and the name of the file we want exported. If we just want the metadata, then we can use the type XML option, and that will give us just the metadata for image 52 rather than the pixel data. And after running those two commands, as you can see, we've got two files in our local directory, one which is the OME TIFF and one which is the OME XML. We can also download images, and these download files in their original format, and they download file annotations as well. So in other words, files we've uploaded using the upload command. So in the first example, we give it the file annotation and the ID, and that downloads the thing we uploaded before, which I think was called toxini, but it's downloaded it as new.tmp. And then in the second case, we're downloading an image, and we want it saved as original.tiff. Pardon me. In this case, we can only download images that are single file images at the moment. That's something we're looking to improve. So deleting data. The delete command deletes entire graphs of data based on the ID of the top node. So in other words, if you delete something that has other objects underneath it, that can be deleted because they don't belong to other people or they're not already linked to other objects, then the entire graph will be deleted. There are various arguments. You can include specific objects, you can exclude specific object types, you can have a detailed report on what has been deleted, and then finally there's a dry run mode which will give you a report of what would have been done. This can be very useful if you're doing a complex delete, because it's useful to know in advance what's likely to be deleted before you run the delete command. So here's an example. We delete image 52, we do it as a dry run with a report, and we get a list of the deleted objects. This is quite a long list because it includes all sorts of information about the channels and logical channels, etc. In this case, I'm just highlighting three particular things. So it would delete the image annotation links. So these would be the links to the various annotations. It would delete the map annotation itself and the image itself. Now the reason it doesn't delete some of the annotations and only deletes the links is because by default it has the same behavior as Insight, where the tag annotations and comment annotations are not deleted, and file annotations are not deleted by default. So the links are deleted, but the original annotations are still left up there, so you still have your tags to work on and you still have your file annotations to use. In this second example, we want to say, well, we really do want to delete the tag annotation and the file annotation, so we use the include option, and then as you can see from the deleted objects now, we're deleting some annotation links, and we're also deleting the tag annotation and the file annotation. We can also delete objects buried further down the tree. So in this case, we use a thing called a skip head. So here we're saying delete all of the images under project 2. The 2 at the end refers to the project rather than the images. And again, if we do it with the dry run, we can see the dataset image links have been deleted because we're deleting images, so they're no longer attached to the dataset. The images, the original files which are represent the uploaded images, and things like the pixels and the file sets are also deleted. Again, there'll be a lot more here, which I've just truncated for this slide. We can also move things. We can move things between groups, and we can change the ownership of objects and give them to other people. To move objects between groups, we just provide the group ID. This is where a user might want to move something from one of their groups to another of their groups, so they can share it with people, or so they can change the privacy. Again, it moves entire graphs of data based on the ID of the top node. In this case, nothing is excluded by default, so the whole graph would be moved, unless things obviously belong to other people, in which case links would then be broken. We can do, so here's an example rather. So we try to change the group of the original file, and we're told we can't do that because it's owned by the file annotation, and this is because files on their own can't be deleted if they're already connected to something else. So if we go down to the next level, we see we can move the file annotation, and this would include the file annotation in the original file in the move, or the change group rather. But what you notice at the very bottom here is there's a deleted object. This is the image annotation link, because in order to move the file annotation, it's had to break the link with the image because the image is staying behind. Pardon me. Exactly the same as delete, skip head can be used to move all the images from one group to another group that are under a given data set or project or screen, for instance. Changing ownership. This transfers ownership of data between users. Again, it's the entire graphs of data. Here there are some restrictions. An admin user can transfer ownership from anyone to anyone. A group owner can only transfer ownership within the group. So those are the two key roles. A user themselves who isn't an owner or an admin can't transfer ownership. They can't just give their data to someone else. They need to get a group owner or an admin to move the data for them. Again, things can be excluded or excluded. Pardon me, and here are a few basic examples. And as you can see on the lower lines here, we can actually pass more than one object and ID on any given line, and this applies to pretty much all the commands in this talk. So we can move 3 images by using image colon 51, 52, 53, for instance. So there is more information on the CLI. There's more help for users, admins and developers on our website. If you go to the original Reveal.js version of this talk on downloads, you'll be able to use these links directly. And thanks for listening, and thanks to the CLI team, the wider OME team, the user community, and to our funders. Thank you very much.